In this video, we'll look at how to make particle effects that react to gameplay. Here, we'll have a player character with different sorts of data in it, such as the location and the health. And we'll create a particle controller that can use this data to then affect a Niagara particle system. Here, we'll look at two different ways of getting data from the player character into the particle controller to control our particles. We'll look at both having the particle controller ask for data in an example with the location, and the particle controller can receive broadcast data from the health using event delegates. All right, we will be creating a particle system that reacts to the player. In this example, we'll change the color of the particles based on the player's health, and we can also change the size of the particles based on the player's height in the world. So as the player goes up this ramp we have set up, the size of the particles will change, and as the player gets damaged, the color of the particles will change. Now, to do this, I've previously set up a very simple health system. In here, you can use any sort of health system in your game. This one's just an example for us to start from. Here, the health can be increased and decreased using input actions. So on my keyboard, I have that set as Q and E keys. And from that, I just increase a value called health, up or down for the different keys, and save that new health. Then I've created an event delegate that sends out a message saying what the current health and the max health are after the health has been changed. Now, in the map, we can see I've also created a simple health bar. And this health bar listens to that delegate, and as I press the Q and E keys, I can change the health of the player. Now, from that basis, we can go ahead and look at how to use that health value and the player's location to change a particle in the scene. We can go ahead and open up our content drawer, and we will make a new Niagara system. Here, I'll use the example of this hanging particulates Niagara system. We'll create that, call it NS particulates. Particules, all right, that's fine. Now in here, you can see on the far left, we have our particles hanging around. We can add user parameters that will allow us to adjust the values of the particle system here. Add a new user parameter. We'll look under common. Here we'll add a linear color. Can call this health color. So this will be, we can modify this health color in order to then modify our particles. And we'll later need some way of determining what the health is and turning that into a color. Now we can add another. We also want to modify the size. With that, we can use a float. And we'll call this, let's call it size. That'll be the size of our particle. Set the default size to 1 and the default color to white. Now these values, these parameters don't do anything yet, and we need to set them in our particle system. So in here, let's look at our initialized particle. When we first create it, there's a color in our color mode. Go ahead, drag in our user health. And then for our size, we can set our sprite size in here. Right now it's a random value. Let's do just single uniform value and drag in our size. There we go. Now if we go down to our scale color, you can see our color value changes over time. I'll drag that color in there as well. Now you can have this spawn more particles so that we can better see what's going on. So I'll change this from 50, change it up to 500 particles. We should get a lot more particles. Then I'll also make this bigger. Let me go ahead and move this over. In our scene, I'll drag out our particles so we can see the size of it. About here. Now let's go ahead and make this bigger. In the particle system, we can open up our shape location. This will be the shape of where the particles are being spawned in. This is currently set to a box. I'll set this to 1,000, 1,000, 1,000. There we go. Now we're spawning those within that box of 1,000. I'll go ahead and just kind of center it on this step here. All right, now we can go ahead and close that. So we have our basic particle system set up in our scene. Now we'll need some way to control it using our data from the player character. So we could go ahead and create a new blueprint. From actor, we'll call this BP particle controller. And before we forget, let me drag that out into the scene. I'll just reset its transform to be at 0. Now this particle transform, or this particle controller, we'll go in here to its event graph and delete these existing nodes. Now first, let's look at a way that we can modify these particles based on the player's health. So in our third-person character, I have these delegates that are currently being used by the UI system. I'll hit play and show that again. This UI can show this bar depending on the player's health value out of 100. We need our particle controller to also listen to those event delegates in our third-person character here. So from this, in our particle controller, we can find the player character and get player character. This we can cast to our third-person character. I'll convert this to a pure cast. We don't need to perform any check. We're only using the third-person character here. If you're using other characters, you can determine whether or not you have a successful cast. But from this, I will bind to our health changed event delegate. Now, if you have your own health system, you may or may not have this event delegate already created, or this event dispatcher created. So you can go ahead and create a new event dispatcher, name it whatever you want, and give it inputs up in this top right for the health and maximum health. I'll delete this example one. And then you can call the health changed just whenever your health is changed in your health system. Back to our particle controller. Here we have an event, a bind to event that has no event in it yet. So we'll need to create a new event here. To do this, we'll drag off our event. And I'll do this option for event dispatchers create event. Now in this option, we can choose a function. We can have it create a matching event or a matching function. In this case, I'll do create a matching function, and it'll automatically create a new function for us that, if I go back to the event graph, is plugged in properly to our bind to health changed event. So if I compile, that looks good. Now we'll change this automatically generated name, and we'll call this on health changed. Open up our on health changed. Now let's drag off of this and test and print out the health. So if we go into the game, as I change the health, we could see it's printing out from values from 100 all the way down to 0 as our health changes. So we have that data from the third-person character into our particle controller. So I'll delete this. Now that we have the health and the max health, we can determine a ratio between the two to get a value between 1 and 0. So we could take the health and divide it by our max health. So for example, if our max health is 100, our current health is 100, we divide that out, we get a value of 1. If our health is 0 divided by 100, then our percentage is 0. So this will give us a nice health percentage, or like a decimal between 0 and 1 that represents the player's health. We can drag off of this. I'll promote it to a local variable here, and let's call it health percent. This will be a value between 0 and 1. And using this health percent, we need to find some way to use this percent to determine a color and then modify the particle system. Now, we don't currently have any way of referencing our particle system in the level. So for this example, we'll directly tie our particle controller directly to this particle system in our map. In here, in variables, I'll add a new variable, and this one can be, let's see, of type Niagara actor. Click on that. So that's an actual Niagara system that's already in the level if you have one existing. If you don't have one, then you can dynamically spawn them in the level and then have your particle controller connect to those new dynamically spawned Niagara actors. But here, since we already have one in the level, I'll just hard set this and we'll call this Niagara system. And we'll set that as private instance editable. That way, if we go to our map, we can find our, let me collapse this, find our particle controller. We'll have an option for our Niagara system. I'll lock this window in place. That way, when I click away, I could click on our particles and drag that in to our current Niagara system and unlock this window. So now this particle controller has a direct hard reference to our particulates. If you didn't want this hard reference, one other thing you could do is in the start of your particle controller, in the event graph on begin play, you could do a get all actors of class and find all particle systems in the level and then update all of those particle systems based on the player's health. But here we'll just do the one with this hard reference. Now that we have that reference, let's look in our on health changed. So now we have this Niagara system, we can drag this in to our on health changed event, and we're able to modify this. So the way to modify the system with a color, we can look up set parameter. We get all these options for set Niagara variables. This particle system here, and we'll go ahead and choose set color parameter. So what this is doing is getting our Niagara system actor, and it actually has a Niagara component within that actor. And we can set a specific color parameter in that component in our Niagara system actor. I'll go ahead and make this bigger. Now we need the actual name of the parameter that we're going to set. So let's open back up our VFX, our particles. Here I called it health color. Back to our particle controller, call this health color. Now this name has to match exactly. Now we need some way to determine a color. One way we could do that is using a curve. So we can open up our content browser, have a curves folder here. I can go to miscellaneous curve, and there should be a curve linear color option. We'll select that, call it curve C underscore, let's call it health color. Open that. So now here we have a scale from 0 to 1, and we have a gradient color. So we can think of this as 0 being 0 health and 1 being full health. Let's move this off to the side and go to our particle controller. Now, to determine this color, we'll need a reference to this new curve we've made. So we could go ahead and make a variable in our particle controller, call this health curve. And this will be of type curve let's see, curve color. We'll have curve linear color. We can drag that in, compile. Now for the default over here on the right for this health curve, we can choose our health color. So we're grabbing this new health color out of from this color gradient, currently from white to black. From our health curve variable, we can get a color, get linear color value, and our in time can be our health percent. So this in time is the value along this x-axis from 0 to 1 in our curve. I'll make this bigger. So there we go. We get our color, and we can directly put that into our set color parameter and connect that up. So we now should be setting the color along this curve based on the player's health for this particle system. Let me make this color curve bigger. To focus on these specific points we have, you can hit Control A to select everything and hit F, and it focuses on the points we have. Here, let's try making, let's say the start color is, let's make it a blue of some kind. And when the player is low on health, let's make it red. And we'll have a gradient between the two. Go ahead, close the health color for now. And look at our, back to our map. We'll hit play. And right now we probably won't see anything. We have the white particles. So we don't currently set the starting point for the particles. So we'll have to go back and set the starting point. But then now as soon as I change the player's health, we can see it updates the color when the health changes to blue. Then as the health goes down, put it like half health. We're in this like purple color. Set the health all the way down. And now we're at this red. Let's see if it works the other way. Get more of the purple and blue as we get back up to full health. Awesome. So let's look back at our particle controller. So this function here on health changed, we're only setting the color when the player's health changes. But that means our initial color will be this default white color of our particle system, since the player's health doesn't change at the beginning of the game. So how we could deal with that is in our event graph, we can update the current health color just at begin play based on the player's health. So to do that, let's drag in our on health changed. Can connect that here in our begin play so we immediately update it. And here we'll need some way of getting the health and max health. We look at our third person character. I have a function in here called get health, and it just returns the health and max health values in a return node. So we could go back to the particle controller. Now, depending on however you implement your health system separately from interacting with the particles, as I'm showing here, this will be a bit different for you. But here we'll have this player character, and we'll grab their health variables using that function I showed. Since we're making multiple references to this player character, I'll go ahead and just promote this player character, third person player character, to a variable. I'll rename this just as third person character. Connect that in instead. And then we can drag in the third person character as well over here and look at get health as that function and connect health and max health up. Now when we play, we should start with the particle systems being changed to blue immediately. There we go. We have our blue particles and purple to red as we lose health. Now, this is one way of getting data into the particle system using these event delegates. Now let's look at another way to get data into it. So instead of an event delegate, we'll get data on the fly just with a hard reference. So to do this, we'll look at our third person character. Here we'll have our player. We'll have this player as a certain position. We'll use the player's height in the world to affect the size of our particle system. So as the player goes up in the world or down, then the particles will change size. Now in here, this actor will have a certain location, and that'll be we could get that using a get actor location node. So our particle controller, we can create a function that'll allow us to update the particle size, similar to how we created a function that changes the particle's color for the health. So we'll make another function in our particle controller, create function, and we'll call this update size. So this will update the size of the particles based on the player's height. Now, if we go back to our event graph, we need some place to call this update size. Let me condense these down a bit. Now we can call update size at the beginning. So we immediately start with the correct size, similar to how we started with the correct color. Move this over. And we also need some way of updating the location over time. So here we can create a timer to do that. And we'll do a set timer by function name. So this timer will allow the function to be called over and over throughout the course of the game. So here I'll set a time. Let's just update it every half a second. We don't need the particles being updated every tick. You could do this in a tick function, tick event, and then call the update size function in here. But we don't necessarily need to do that every single frame of the game. So instead, let's just do it every half a second. And we'll select looping, max once per frame. Probably won't ever happen with it with a time of 0.5 seconds. And then we'll need a copy in our function name here. This will be update size. Now this function name has to match exactly. So this should occur every half a second. And we could test that out if we go to update size, print, just print hello. If we go to play, now we'll print out hello every half a second there in the corner. All right, let's go back. Particle controller, delete our print. Now in here, we need to get the player's location. So we already saved this third person character variable. We could drag that in and get. Here we could do get actor location. And we want to change the particles based on the player's height. So we can split this structure and get the Z value. Here I'll just promote it to a local variable so we have easy access to it. And let's rename this as player height and connect that to our update size. All right, so we have our player height, and we'll need to change that into, like, convert that into a size. So again, we can look at creating a curve to do that again, like we did for the color. And then we'll also need to update the particles based on that size. So for the updating the particles, we already have our Niagara system. We can drag that in. And here we could do set parameter float. And it'll be under our effects components particle system, set float parameter Niagara component. We can connect that up to our player height. Now our parameter name, let's look back in our particles, was just called size. In the particle controller, we can rename this as size. We can clean this up a bit. For the parameter, now we can look at converting our player height into a size using a curve. So we could create a new curve, go to miscellaneous curve. This time we'll do a curve float. Select, we'll call it C Let's do player height to size. Open that. Now in here, this we will want to convert any height in the game to a particular size. So let's first add a key. This first key, let's put at a height of 0, and we'll do a size of 1 for the particles. Now right click, add another key. This new key, let's say a height of 5,000 units and a size of, let's go much larger at a size of 10. I'll hit Control Alt and then hit F. Maybe. I don't know if it took my first key. Let's add that back in at 0, 1. Go Alt F. There we go. Must not have accepted the first key. So in here we can see below 0, we have a flat line, so it'll always be size of 1. Anything larger than this 5,000 units will always be a size of 10. Now let's see in the game. We come up here, how high is this? Or this, the highest cube we have here is 400 and 500. So let's, instead of setting this to 5,000, let's go down to 500. So we have this curve from our height of 500 to a size of 10. Go back to our particle controller, and we can add a new curve in here like we did with our health curve. This one can be our size curve. Instead of curve linear color, this will be curve float. Go ahead, drag that in. And save and compile. We'll set our default size curve to our player height to size. Drag off of that and get float. Get a float value. Our player height will be our in value. I'll rearrange these a bit. And that can go into our set float parameter. Compile, save. So now we should be changing our size of the particles based on the player's height in the world. Let's hit play. So we have here our smallest size of 1. As we go up, some of them should start to get a bit bigger. There we go, the new ones that spawn in. So we go up another level. Looks like we're starting to get even bigger particles. And now here at the top, we should start be getting the biggest particles. And also as we lose our health, they'll start to turn different colors. So we go back down, we'll get small particles of that color. And back up. All right. Now I hope this was helpful to see how to influence various parameters of the particle systems using the player's data. So here we have the health data and the player's height. And you could do all sorts of things with, with this kind of setup to modify particle parameters. Like you could do a snowstorm that is made out of particle system, that as you go up the mountain and get higher up, the particles become bigger or more frequent. It's all sorts of different things. Let me know if you make anything with this. I'd love to see it, and I'll see you in the next video.